Okay, so for 5-7 inequalities in one triangle, originally I broke these notes up into 2 days, but with the way we have things going now, it's very difficult to break a section up on Pearson Realize or Savas. So we're just going to teach it all together as once, but we'll make sure you guys have time to answer all the questions associated with this, okay? So for inequalities in one triangle, we're going to start off with the first page of notes. We have this exterior angles theorem right here. The measure of an exterior angle is greater than the measure of each of its remote interior angles. If you think back to topic 3-5, I blanked on it for a second, where we learned about the exterior angles theorem, where if we add up the two remote interior angles, it's going to equal the exterior angle, right? Now, this is just logically following that same thing. If we have to add these two together to equal this one, neither one of those two angles can be greater than angle 1. So that's really simple. Don't forget that inequalities, the whole name of this section is greater than, less than, or greater than, less than, equal to, all of those things. Those are all inequalities. So that's what we're talking about in this section. Sorry if that didn't make sense. So right here we can see an exterior angle is going to be greater than one of its remote interior angles or greater than the other remote interior angles. And that's because of that triangle exterior angle shortcut that we learned a while back in 3-5. Highly recommend you look at your notes for that. And that's why this theorem works, okay? So let's talk about sides and angles theorems. This seems a little bit confusing at first, but the point is here, xz right here is a longer side than xy and yz, okay? And mainly it's saying than xy. If this is a longer side, then the angle opposite of it is going to be the bigger angle. So this red angle is going to be bigger than this blue angle because the red side is longer than the blue side. Okay, we're not doing this just based off assumptions. It's saying if this is true, if the side is greater, then the angle is greater. And it works in reverse too. If the angle y is bigger than angle z, then the sides opposite of it, remember opposite, okay, let me draw this out in some different colors for you guys. If I have a triangle, okay, red, blue, and green. I don't know if you guys can see the color difference here. Let me zoom in. The angle opposite of red, okay, is over here, okay? This angle is opposite of red. And this angle, or if we want to think about it like this side is opposite of this angle right here, okay? That blue angle. Same thing right here. When we mean opposite, we mean across from, okay? So those are opposite of one another. So the same thing keeps happening right here. The longest side lies opposite the largest angle. So if y is the largest angle, xz is going to be the longest side, okay? And it works the other way too. The shortest side lies opposite the smallest angle. So if angle z is the smallest angle, then xy must be the shortest side. If you want to think about opposite as the one that doesn't include that letter, okay? See how I talk about xy goes with z? That's because xy isn't touching z at all. It's opposite of it, okay? It works backwards too. So we could read this as the largest angle lies opposite the longest side. So if xz is the longest side, then the angle opposite of it, angle y, must be the largest angle. And the same thing is true. The smallest angle lies opposite the shortest side. So if xy is the shortest side, I think I even said that backwards. Smallest angle, so z is the smallest angle, xy is the shortest side. But we get the idea here, okay? Let me show you an example problem based off this, and then we'll go back and do the other set of notes. So first up, we have this example problem on page 230. Let it focus. Struggling a lot to focus. Maybe. There we go. Focused a little bit better. So we have these rows right here with their lengths. And so what we do here is I said it's triangular. The architect wants to place a bench at the corner with the largest angle. So here's the thing. We know what each one of these sides are. So which one's our longest side? Well, very clearly that's Hollingsworth Road. So what our theorem tells us is that the biggest angle is opposite of that side. So it's going to be on the corner of MLK and Valley. So this is going to be the biggest angle. And try to think for a moment, where would our smallest angle be? Would it be to the left or to the right? Well, it's going to be up here on the right side because 105 is smaller than 120. So this is going to be our smaller angle. And the same thing works in the reverse. Okay, if we have this problem that says 58 and 62 degrees, and it's wanting us to list the sides in order from shortest to longest, okay? Shortest to longest. So the way we do this, well, first I have to know what this angle is, but we know triangles equal 180, so I can just do some math off to the side here. I can say I know x plus 58 plus 62 must equal 180. Well, if I add those together, that's going to give me 120. So x must be 60. So if this angle is 60, and I'm wanting to list from shortest to longest, okay? So the shortest side is going to be opposite the smallest angle. Well, I have 58, 60, and 62. So 58 is my smallest angle. So the side opposite of that, TV, is going to be my shortest side. So now I've narrowed it down between A and D. So now let's keep going, okay? Our next shortest side is going to be across from the next shortest angle. So this is 60, or smallest angle. This is 60, so UV is going to be my next one, so it must be A, but we'll double check this. V is the biggest angle, and across from it is our longest side, UT, okay? So it must be A. And so we can figure that out here as well. So that is very important for us to understand about how to get that. Now let's go back to our notes for the continuation of 5-7. So 5-7 continued. I'm including them both in one video. And the triangle inequality theorem. So the way that this works is the sum of the lengths of any two sides of a triangle is greater than the length of the third side, okay? So here's how we do this. I can add up any two sides of a triangle, and it has to be bigger than third, or else it's not a triangle, okay? And so we have to make sure all three of these work. So if I add up the red one and the blue one, it has to be greater than the green one. If I add up the blue one and the green one, it has to be greater than the red one. If I add up the red one and the green one, it has to be greater than the blue one. Okay, and all three of those have to work, or else it's not a triangle. So the questions that come in this section are, can triangles have sides with these lengths? So we check 3, 7, and 8. And we're like, that could make a triangle, but we have to double check the triangle inequality theorem. So we say, is 3 plus 7 greater than 8? Well, yeah, that works. Is 7 plus 8 greater than 3? Well, yeah, that works. Is 8 plus 3 greater than 7? Yeah, that works. Well, then, yes, this must be a triangle. We need all three of them to work, because if one of these didn't work, then it wouldn't be a triangle. Same thing down here, 5, 10, and 15. Well, 5 plus 10, that's only 15. Is that greater than 15? No, it has to be greater than. It's not greater than or equal to. It doesn't say that. So it does not work, okay? And this is actually the exact same example problem from the book. I just did it in our notes so that way we could understand it better. But we can see that's exactly how they do this problem right here, okay? So we keep that in mind for the problems that we're doing, whether we're listing angles from smallest to largest. Remember, 3x is bigger than x. Remember, the biggest angle, if we have a 90-degree angle, that's automatically going to be the biggest angle in a triangle. So please keep that in mind. When you're checking if triangles work, can a triangle have sides with these lengths? Make sure you check all the sides. And then this question is very important, okay? So this is example problem 6, and I'm going to do this example problem out here with you guys. Hold on one second. Gotta get my journal. So right here, it says that the possible sides of a triangle sandbox is 5, 8, and x. Okay, if it ever gives you two of them, call the third one x. Okay, don't just be like, it only gives me 2, I don't know what to do. Call it x. Well, now we know exactly what to do here. We know that 5 plus 8 must be greater than the third side, right? And we know 8 plus x must be greater than the third side. And the last one, we know 5 plus x must be greater. 5 plus x, not times, plus x must be greater than the third side, okay? So I can solve these for x. Well, 5 plus 8, right there, we have 13. Okay, let's solve for x over here. Okay, I want to subtract 8. Subtract 8. X must be greater than 5 minus 8 is negative 3. And then over here, I have minus 5, minus 5. X must be greater than 3. So this is how I actually write this out, and this is how you're going to write out all of them. You're going to say x has to be greater than what number and less than what number. Well, we only have one that x has to be less than. X has to be less than what? Well, x has to be less than 13. So we can find this number. The little trick here is by adding the other two numbers together. That always tells us what x has to be less than. But now for x greater than, we have two of them here. And here's the issue. I have x greater than negative 3 and x greater than 3. Well, let's think about this. Can a side of a triangle be negative? Well, no. But also, if x is greater than 3, doesn't that automatically make it greater than negative 3? So we're going to go with the one that makes more sense here. We're going to go with x greater than 3. We don't really need this one at all because it's solved for. If x is greater than 3, it's automatically greater than negative 3. Okay? So we say, and the trick here is you just do the big one minus the little one. Okay? That's how we get this number, and we can add them together to get the big number, subtract to get the small number. And this is how we write our answer for these problems. X has to be greater than 3 and less than 13. That's how our answer should be written out. Okay? That's very important for these type of questions right here. Okay, so if it's just asking, can it have, you're just doing the check that we did in the notes. You're just checking, do all three work? If it's what are possible lengths, that's when you have to write out. X has to be greater than what number and less than what number. So that's how you do 5-7. I know it's kind of a long section. I know it's originally separated into 2 days. I'm sorry that we couldn't separate it into 2 days now. If you have any questions, please text me on Remind, okay? And if you're doing textbook problems, you need to do all of these problems involved here, okay?